solve the system linear equations using matrix method. So first we put the given system linear equation in matrix form. 4, 3 minus 3, 5 multiplied by the variable matrix xy equal to the constant matrix 3, 7. If I call this as A, the quotient matrix, so A times xy equal to 3, 7 equal to 3, 7. Multiplying both sides by A inverse, we'll have xy equal to A inverse times matrix, the constant matrix 3, 7. Call it 1. Now let us work out A inverse and substitute it here. What is the value of A? The quotient matrix, it is 4 minus 3, 3 minus 5. To work out A inverse, you know it is 1 by determinant A into adjoint A. So let us first find out determinant A. The product on the main diagonal is minus 20 and minus plus 9. So it comes out, determinant A comes out negative 11. And now let us find out adjoint A. Adjoint A, you know, is the transpose of a matrix obtained by replacing each element by the cofactor, and you know the sign convention. So for 4 it is negative 5 with the same sign because positive times you have to take. So negative 5, for negative 4, negative 5 it is 4 with the same sign. For 3 it is negative 3 with the change sign, so it will be 3. And for negative 3 it is 3 with the change sign, so it will be negative 3 here. Now take the transpose. The elements of the first row, negative 5, negative 3 goes to first column, and that of second row, 3, 4 goes to second column. So what is the value of A inverse now? A inverse is 1 by determinant A into adjoint A. And what is the value of determinant A? 1 by, that is minus 11. So we get A inverse as negative 1 by 11 into adjoint A, that is minus 5, 3 and minus 3, 4. And now replacing it in 1. So from 1, now the required variable matrix is A inverse, that is minus 1 by 11 into minus 5, 3 and minus 3, 4 multiplied by the constant matrix 3, 7. Keeping minus 1 by 11 outside for a moment, multiply the two matrices row to column, you know. So it will be minus 15 plus 21. Repeating the process with the second column, second row, you get minus 9 plus 28. That is minus 1 by 11 times, you get 6. In the second column, you get, in the second row, you get 19. And now multiplying both the elements by negative 1 by 11, you get negative 6 by 11 and negative 19 by 11. So this is the value of matrix xy. Equating the respective components, you get the value of x is negative 6 by 11 and the value of y equal to negative 19 by 11. So we have solved it using matrix method. Question 10. Solve the system linear equations using matrix method. So same procedure, you write in matrix form 5, 3, 2, 2 multiplied by variable matrix and is equal to the constant matrix 3, 5. Multiplying both sides by A inverse. What is A? To this variable matrix I am calling A, keeping xy and 3, 5, these two column matrices same. And now multiplying both sides by A inverse. On the left you are simply left with xy. On the right side I write symbolically A inverse multiplied by the constant matrix 3, 5. Call it 1. Now it is a matter of finding the value of A inverse and substitute it in 1. Now here the variable matrix A, the quotients of the variable are 5, 2, 3, 2. And to find A inverse, that is 1 by determinant A into adjoint A. So let us work out determinant A. It is 5 into 2, 10 minus 6, that is 4. And now adjoint A. Adjoint A, is the transpose of the cofactor matrix. The sign convention is already there. So for 5 it will be 2, for 2 it is 5 with the same sign plus plus, and for 3 it is 2 with the change sign, so minus 2, and for 2 it is 3 with the change sign, so minus 3. And now take the transpose. The elements of the first row, that is 2, negative 3, goes to first column, and the second row minus 2, 5 goes to second column. So we can work out A inverse. A inverse, is 1 by determinant A into adjoint A. Replacing the values, the value of determinant A we worked out 4, so it will be 1 by 4 times adjoint A is 2 minus 2 minus 3, 5. So we have worked out A inverse, now substituting it in 1. So from 1 we get xy equal to A inverse. A inverse is 1 by 4 times 2 minus 2 minus 3, 5 multiplied by the constant matrix 3, 5. Just take the matrix multiplication. It will be row to column. So it is 6 minus 10, and in the second row similarly minus 9 and plus 25. So it is 1 by 4 times 6 minus 10 minus 4 and 25 minus 9, 16. Multiplying both the elements by 1 by 4, you get minus 1, 4. So finally you get the matrix xy equal to minus 1, 4, equating the respective elements. You get x is equal to minus 1 and y equal to 4 is the required solution.